Okay, in this video we're going to talk about Unit 3, Objective 3, Antidifferentiation by parts. And what we're going to use antidifferentiation for parts by is kind of to get rid of our product rule in antiderivatives and integrals. So our rule is going to be, if we have the antiderivative of some function u times some function dv, that's going to be equal to u times v minus the antiderivative of v du. So u times v minus the antiderivative of minus the antiderivative of v du. So what we're going to start with is, on this left-hand side, we're going to be given this antiderivative of v du, which means we're starting with u and we're starting with dv. If we look at our answer, we have a u, a v, and a du. So we're going to need to take the derivative of u to figure out what du is, and we're going to have to take the antiderivative of dv to figure out what v is. And the biggest trick to all of this is trying to pick the correct u. If you pick the incorrect u, just like with u substitution, your problem's not going to work out. Luckily, we have an mnemonic device to help us figure out what our u is going to be. And that mnemonic device is LIPET. L-I-P-E-T. And what that stands for is logs, inverse trig, polynomials, exponentials, and regular trig. This is the order that we want to look for our u when we're picking, when we have this antidifferentiation by parts. Now, the big one, the one that's going to happen more often than not, is polynomials. And the one thing we need to remember about polynomials is that x just by itself, or x squared, etc., are polynomials. The majority of the time, our u is going to be something like x or 3x to the third or something like that. So logs, inverse trig, polynomials, exponentials, trig, in that order are how we're going to pick our u for our antidifferentiation by parts. So an example of what this might look like is if we are trying to antidifferentiate x cosine of x. So the first thing that I would want you to think about if you're faced with this problem is, does plain old u substitution work? So if we're trying to do plain u substitution, we would pick u to be x because that's inside of our trig, which means du would be dx. And the problem is we have an extra x left over in front of the cosine, so our u substitution doesn't work. So our ordinary u substitution, the way we're used to seeing it, doesn't work. So we need to think antidifferentiation by parts. And we need to think that, one, because u didn't work, and two, because we have a product inside of our antiderivative. So if we think about LIPET, L, there's no logs, I, there's no inverse trig, P, there is a polynomial right there. So our u is going to be x, which means our dv is going to be everything left over. So our dv is equal to cosine of x dx. So if you remember the last slide, we said we need a u, a du, a v, and a dv. So if I have a u and an x, du is going to be equal to dx, just take the derivative. And if I have a dv, to go from the derivative of v to v, we need to antidifferentiate. The antiderivative of cosine is sine. So now we have our u, v, du, and dv. So our formula says the antiderivative is uv minus the antiderivative of v du. So taking the pieces that we have, we plug them in. So uv is going to be x sine of x minus the antiderivative of v, which is sine of x, du, which is dx. So we're still left with having to take an antiderivative, but this is much easier. We can take the antiderivative of sine of x with no issues at all. The antiderivative of sine is going to be negative cosine plus c, and then we just have to clean it up a little bit because we have that minus negative cosine. So the antiderivative of x cosine x is x sine x plus cosine x. And again, just like with antiderivatives in general, if you want to check your answer, you can take the derivative of x cosine x plus cosine x, x sine x plus cosine x plus c, and you should end up with x cosine x. I'll leave that to you if you want to look at it. Sometimes we're going to get a problem that requires us to do antidifferentiation by parts more than once. So if we have something like this where we have x squared e to the x dx, thinking about our plain old u substitution, we would go to the exponent of e, which would be x. Du would be 1, and that x squared in the front isn't going to go anywhere. So we need to think about substitution by parts. So our u, if we think about Lipit, L logs, we don't have any I inverse trig, we don't have any p polynomial x squared, which means dv is going to be e to the x dx. Du is 2x dx. V, the antiderivative of e to the x, is just e to the x. So we have all of our parts there. So uv x squared e to the x minus the integral of v, which is e to the x, du, which is 2x dx. So I'll rewrite that, pulling our 2 out front. So we have x squared e to the x minus 2 times the antiderivative of x e to the x dx. Once again, if we're trying to take the antiderivative of x e to the x dx, our plain old u isn't going to work. U would be x, du would be dx, and we have an extra x involved. So over in blue, we'll take the antiderivative of just e, or x e to the x dx. So going through the process again, our u is going to be x, our dv is going to be e to the x dx, du equals dx, v once again is going to be e to the x. So for this blue part, we're going to have uv, so e to the x, x e to the x, minus the antiderivative of v, so e to the x, du, which is dx. So we have x e to the x minus the antiderivative of e to the x is just e to the x. So all of this x e to the x minus e to the x is the antiderivative of that. So to put the problem back together, get an answer, we're going to get x squared e to the x minus 2x e to the x. We have a negative here and a negative here, so we're going to say plus 2 e to the x plus c. So our antiderivative of x squared e to the x is x squared e to the x minus 2x e to the x plus 2 e to the x plus c. And again, if you wanted to take the the derivative of that to figure out if we did this correctly, you can. That's up to you. One thing that we can do that could help make this problem a little bit easier is there's something called tabular integration that takes advantage of u substitution. So we'll say when u can be differentiated to 0, meaning if you take the derivative of u over and over and over again and you eventually get to 0, and dv can be antidifferentiated many times with ease. You can use tabular integration to find your problem or your answer. And tabular integration is going to be a lot easier than doing anti-differentiation by parts over and over and over again. So what we're going to do is we'll just do this one through an example. So our example would be the antiderivative of x to the third sine of x dx. So we're going to make two columns to figure out this antiderivative. We're going to say our first column is going to be u and its derivatives, and the second column is going to be dv and antiderivatives. So I'm kind of jumping the gun by making this set of columns. If we were to do this problem with antidifferentiation by parts, we would say u is equal to x to the third, and dv would be sine of x dx. If we look at those two things, if we take the derivative of x to the third over and over and over again, we're eventually going to get to 0. And if we look at sine of x dx, we could take the antiderivative of that over and over and over again without much trouble. So that's exactly what we want to do. So we're going to start with x to the third and sine of x. And we're just going to start taking derivatives on the left-hand side. So 3x squared, 6x, 6, and 0. And we want to take just as many antiderivatives on the other side. So the antiderivative of sine is negative cosine. The antiderivative of negative cosine is negative sine. The antiderivative of negative sine is cosine. And the antiderivative of cosine is sine. So how we're going to use this to get our answer is we are going to take the top left, draw a little arrow across going down 1 each time. We are going to multiply all of the things connected with an arrow, and then we are going to either add or subtract based on the order. So we're always going to take those two things as positive, those as negative, those as positive, and those as negative. So our answer would be x to the third times negative cosine of x, so that's negative x to the third cosine of x. On that next line down we have a 3x squared, a negative sign, but in the middle right here we have a negative, so negative and negative give us a positive 3x squared sine of x. Then we have a positive with a positive cosine, so we're going to say plus 6x cosine x. And on the last one we have a negative and a negative sign, or a positive sign, so we're going to say negative 6 sine of x. And then the last thing we need to do is just put our plus c. So if you wanted to go back to the problem we had before with x squared e to the x and try your tabular integration, see if you come up with the same answer, that wouldn't be a bad idea. That's going to do it for this video. We'll see you in the next one.